Hi guys and welcome back to my channel. This is episode 4 of the carbon cycle and energy insecurity unit over here on my channel. Today we're going to be looking at a balanced carbon cycle. As I say, it's episode 4, so I'll try and remember to link the rest of the playlist up here, but if I forget, which I mean it's me, I probably will, yeah, just go and look for it on my channel. I'm going through the whole geography A-level specification, so there's playlists and playlists of them already out. So go ahead, have a look, see what you need to find and what might help you in your revision. And if there's anything that I haven't yet uploaded, let me know down below and that might be the next series coming out. Yeah, we'll see. So without further ado, let's just get straight on into this video. The natural greenhouse effect. The sun is the natural driver of almost all of the Earth's atmospheric energy. Energy is received as incoming solar radiation from the sun. Dark surfaces on the Earth's surface absorb this solar radiation and then radiate it back as heat. However, that warmth alone is insufficient to permit life on Earth, because it simply would be radiated out into the atmosphere and lost into space, unless something prevented it from escaping. One of the most vital roles of the carbon cycle is the release of carbon dioxide and other gases such as methane into the atmosphere. Together with nitrous oxide, halocarbons, ozone and water vapour are all known as greenhouse gases. They absorb and reflect back some of the radiated heat from the Earth's surface. By retaining this heat, they keep the Earth's surface 16 degrees warmer than it would be, warm enough to sustain life on Earth. The process controlling the amounts of concentration of these greenhouse gases in the Earth's atmosphere affect the global climate, so CO2, HC4, both carbon-based, each contribute to the natural greenhouse effect. Greenhouse gases. CO2 is the most common greenhouse gas and is 89% of the total. Together, they act as a blanket retaining heat, but CO2 has the highest radiative forcing effect, RFE, of all gases emitted by human activities, so it holds on to heat for longer. The enhanced greenhouse effect. The concentrations of several greenhouse gases, including atmospheric carbon, CO2 and HC4, in the atmosphere have increased 25% since 1750, when industrialisation began in the UK, and are now increasing faster than ever. Since the 1980s, 75% of CO2 emissions have come from burning fossil fuels. Most climate researchers believe that this is the cause of increased global temperatures and is leading to an enhanced greenhouse effect. Human activities such as burning fossil fuels and deforestation release natural stores of carbon and nitrogen, which then combine with oxygen to form greenhouse gases. Carbon combines with oxygen to form CO2, and nitrogen combines with oxygen to form N2O, nitrous oxide. Also, as global temperatures increase, so does too the level of water vapour in the atmosphere. Increasing global temperatures leads to greater evaporation of water, leading to greater condensation. This causes increased cloud cover, trapping heat in the atmosphere. Climate patterns, temperature and precipitation. Given that CO2 and other greenhouse gases naturally help to maintain the Earth's temperature, and also determine the distribution of temperature and precipitation, then changing their concentrations is likely to alter these distribution patterns. Temperature. The amount of solar energy reaching the Earth's surface varies at different locations, which in turn influences temperature. The angle of the sun's rays makes solar insolation intense at the equator, but dispersed over a wider area at the poles. Different characteristics of the Earth's surface also affect how much heat is absorbed or reflected, known as the albedo. Snow reflects heat and dark forests absorb it. Heat is redistributed around the globe by air movement, caused by both pressure differences and ocean currents. Precipitation. The heating of the Earth's atmosphere and surface controls the temperature, pressure, movement and moisture content of the air. Warm air rises and cools leading water vapour to condense and clouds to form. Because solar radiation is the most intense over the equator, convection and low pressure systems dominate there. Rainfall is high all year. As the air pressure rises around 30 degrees north and south of the equator, precipitation decreases. clouds rarely form there. In the mid-latitudes, air masses of different characteristics meet, and low-pressure systems bring rainfall. Nearer the poles, precipitation falls as the air cools further and is dense and dry, creating polar deserts. Regional and seasonal variations also occur because of the effects of relief and the migration of global pressure patterns and wind systems as the sun moves north and south. Regulating the composition of the atmosphere. Photosynthesis is a vital process in regulating the composition of the atmosphere. Phytoplankton in the oceans sequester CO2 through the process of photosynthesis, pumping it out of the atmosphere and into the ocean store. This action is known as the biological carbon pump, which we looked at 2 weeks ago, and the process is transferred between 5 and 15 gigatons of carbon from the atmosphere to the ocean each year. Terrestrial photosynthesis, land-based, enables plants to sequester 100 to 120 gigatons of carbon dioxide a year. This is then released back into the atmosphere through respiration and decomposition. Different ecosystems absorb CO2 as a result of photosynthesis. Anything that affects the level of phytoplankton in the world's oceans, either in a positive or negative way, or the area of land covered by forest through deforestation, changing land use, will have an impact on the level of carbon sequestration. This in turn will affect the composition of the atmosphere. Tropical rainforests are ideal for plant growth, which promotes photosynthesis. The marine equivalents of rainforest in terms of plant growth are coral reefs and mangroves. Warm, tropical shallow waters are ideal for both. Deserts, meanwhile, are areas of sparse vegetation, hence relatively little CO2 is absorbed there. The increasing melting of Arctic sea ice means that greater expanses of ocean are now exposed to direct sunlight, because seasonal thaws there last longer. Increasing photosynthesis by phytoplankton is now resulting in algal blooms in Arctic waters. As a result, more CO2 is being absorbed there. Soil and carbon. Carbon is vital in soils. Organic material is the medium by which carbon passes through the system, and it also supports microorganisms that maintain the nutrient cycle, break down organic matter, provide pore spaces for infiltration, and storage of water and enhance plant growth. Without carbon, the nutrient and water cycles cannot operate properly. The amount of carbon stored depends on the system. The amount of organic carbon stored within the soil is equal to the inputs minus the outputs. The size of the store depends on different biomes. Healthy soils usually are dark, crumbly and porous, contain many worms and other organisms, provide air, water, nutrients for microorganisms and plants to survive. They also contain more carbon and organic matter. They sequester carbon, improve resilience to wetter weather because they enable infiltration and percolation of water, reducing soil erosion and flood risk. And they also retain moisture, which regulates soil temperature during heat waves and reduce the effects of drought. In the Northern Hemisphere, winter's organic decay increases the amount of CO2, while spring's renewed plant growth causes a reduction, as new plant growth absorbs it. If winters become shorter, it's possible that less CO2 will be released. It's possible, too, that climate change will create a natural response, and that more CO2 will be absorbed, altering balance. Fossil fuel combustion. Fossil fuels are extremely important long-term carbon stores, comprising carbon locked away within the remains of organic matter. Today, most of the world's oil and gas is extracted from rocks that are between 70 and 100 million years old. Coal is even older. When burnt to generate energy, the stored carbon is released, primarily as CO2, into the atmosphere. It has several implications. Balance. Earth's carbon reservoirs act as both sources, adding carbon to the atmosphere, and sinks, removing it from the atmosphere. If the sources and sinks are equal, the carbon cycle is said to be in equilibrium. Maintaining a steady amount of CO2 in the atmosphere helps to stabilise global temperatures. However, human activities have increased CO2 input into the atmosphere without any corresponding increases in the natural sinks, such as oceans and forests. Hence, atmospheric stores of carbon have increased, which is widely believed to be the main cause of rising global temperatures. The process of fossil fuel combustion has altered the balance of carbon pathways and stores. With carbon being released in large amounts of stores, flows have generally increased. Since the late 1950s, with the most abundant flow, inputs of atmospheric CO2 has been measured by the Hawaiian Volcanic Observatory. Their findings show an alarming increase in the levels of atmospheric CO2. Implications for climate. Rising levels of atmospheric CO2 are believed to be causing global temperatures to increase, causing climate change. However, the increases will probably vary. Across Europe, annual average land temperatures are projected to increase more than the global average. The largest increase is expected to be over the Eastern and Northern Europe in winter and over Southern Europe in summer. Annual precipitation is projected to increase in Northern Europe and decrease in Southern Europe, increasing the differences between the regions that are currently wet and those that are dry. Extreme weather events are also likely to increase in both intensity and frequency. Arctic amplification. The Arctic region is warming twice as fast as the global average. This phenomenon is known as Arctic amplification. Melting permafrost releases CO2 and CH4, increasing the concentration of these greenhouse gases in the atmosphere and leading to increased global temperatures and further melting. Climate change is altering the Arctic tundra ecosystem. Rapid warming has contributed to extensive melting of sea ice in the summer months, as well as greatly reduced snow cover and a reduction in permafrost. Shrubs and trees previously unable to survive in the tundra have started to establish themselves. The same is true of animals. In Alaska, the red fox has spread northwards and now competes with the Arctic fox for food and territory. But not all scientists agree that melting permafrost will release stored carbon as carbon dioxide and methane. Some studies show that as permafrost thaws, the stored carbon will remain in the soil and is used by new vegetation. Warmer temperatures accelerate decomposition, releasing nutrients and carbon. Nutrients encourage plant growth and the removal of carbon from the atmosphere through photosynthesis, decreasing the levels of CO2 in the atmosphere. Implications for the hydrological cycle. Projected changes to temperature and precipitation patterns across Europe would also impact on the hydrological cycle. In the summer months, much of Europe's water comes from the melting alpine glaciers. But according to scientists, by 2100, the Eastern Alps will be completely free of ice altogether, together with part of the Western Alps, affecting the hydrological cycle. Precipitation in the form of snow could diminish and rainfall patterns will change. River discharge patterns may also change, with greater flooding in winter and drought in summer. As alpine glaciers melt, water flows lead to increased sediment yield. Once the glaciers have retreated, discharge and sediment yields fall and water quality declines. And that is the end of episode 4 of this series. I hope you enjoyed. Please do subscribe down below as I'll be uploading the next one next week. Next week we're going to be looking at energy security, so stick around to see that, and I will see you Monday at 4:30 p.m. Bye guys.